What determines the shape of a covalently bonded molecule? We know that electrons are the same charge, so they should repel. The Vesper theory states that pairs of electrons in a molecule will be repelled from one another as far as possible in a 3D space. We use the Vesper theory to determine the shape of covalent molecules. Shape is determined by the electrons because they will arrange themselves as to minimize repulsion as much as possible. There are different magnitudes of repulsion between pairs of electrons. The repulsion of non-bonding pairs of electrons and non-bonding pair of electrons is greater than the repulsion of non-bonding pairs of electrons and bonding pair of electrons, which is even greater than the repulsion of bonding pairs of electrons and bonding pair of electrons. Four basic shapes can be determined by the number of bonds in a molecule. The first shape is linear. All diatomic molecules are linear because there are only two atoms to consider. But for polyatomic molecules such as carbon dioxide, two double bonds form between carbon and oxygen, and since there are no non-bonding pairs of electrons on the central carbon atom, the bonding electrons separate as far as possible and you get a linear molecule. Bond angles of all linear molecules are 180 degrees. The second shape is bent. Water is an example of a bent molecule. There are two non-bonding pairs of electrons and two bonding pairs of electrons around the central oxygen atom. According to Vesper, in order to minimize repulsion between them, the bond angle between the bonded atoms is 104.5 degrees. The non-bonding and non-bonding pairs repulsion is greater than the non-bonding bonding repulsion, which is greater than the bonding bonding pair repulsion. The third shape is trigonal pyramidal. When there are three pairs of bonds, a trigonal pyramidal is formed. In ammonia, there is one non-bonding pair of electrons and three bonding pairs of electrons around the central nitrogen atom. The repulsion between the non-bonding and bonding pairs of electrons is greater than the repulsion between the bonding pairs of electrons, and the bond angle between the bonded atoms is 107 degrees. The fourth shape is tetrahedral. Methane is an example of a tetrahedral. Carbon needs 4 or more electrons in order to complete its outer shell, so it bonds with 4 hydrogen atoms. All the electrons are now bonding pairs around the central carbon atom and repel each other equally, resulting in a bond angle of 109.5 degrees between the bonded atoms.